Hello everyone. In this session, let's discuss about one of the most important commodity available to us, which is water. What are the different impurities in water and what are the types of water? So we know that water is one of the basic necessity of life, which is necessary for the survival of all living beings. Next, we also know that water is the one of the most abundant commodity in nature and it is also the most misused one. Although Earth is a blue planet and it contains about 80% of water, out of this 80%, only 97% of water is locked in terms of oceans and sea. And we know that ocean and sea water is very saline. The salt content in it is very much. That is why we cannot directly use it for agriculture and industrial purposes. So out of this 80%, 97% is in form of oceans and sea. Then 2.4% is trapped in polar ice cap and giant glaciers. So we also cannot use the water from the glaciers and ice cap directly because they melt slowly. Then from this 80% of water, only 1% of water is used by man for various development, industrial, agriculture, steam generation, as well as domestic uses. So though we say that water is available abundantly, very less amount of water is there which we can use for our purposes like development, industrial, agriculture. Also we cannot use them directly, we have to still process it. Now what are the different types of impurities in water? Why do we cannot use the water directly? So let's see. The first type is suspended impurity. As the name says, suspended impurity is an impurity which is actually larger in size. So the impurities which we can clearly see with our naked eyes in water, that can be called as a suspended impurity in simple words. So what are the examples of suspended impurities? Like clay particles, precipitates of iron hydroxide, calcium carbonates, bicarbonates, silicates, organic impurities, those which we get from living matter, like some residues or remains of animals and plants, pesticides. Okay, the impurities which have size greater than 1000 angstrom, those are the suspended impurities which we can clearly see. If there are small pebbles in water, I can clearly see it. So it comes under suspended impurities. Next is colloidal impurities. Now, colloidal impurities have size less than suspended impurities. So, like you can see, size range for suspended is 1000 angstrom, more than 1000 angstrom. So, colloidal impurities will have size between 100 to 1000 angstrom. So, those are finely divided impurities like those of silica, alumina, organic waste, which neither settle down nor can be filtered. So this is the difference. Like I said, suspended impurities, those are bigger size impurities which can be easily seen, also easily removed from water by simple filtration technique. Colloidal impurities are again the impurities which can be visible, but those are smaller in size than suspended impurities and they cannot be easily removed by filtration. Suppose I add chalk powder in water, so you can see that the water is not clear, it is having some impurity. But again, you cannot remove that impurity by simple filtration. That is colloidal impurity. Next is dissolved impurities. The impurities which we cannot see, those are in dissolved form, like various metal salts, gases, and organic solids like sugar, alcohols, carboxylic acids, urea. Those are water soluble. So the impurities which we cannot see are called as dissolved impurities and hence they cannot be removed by simple filtration technique. Next is biological impurity. So these impurities in water include bacteria, like they can be aerobic or anaerobic, algae, fungi, virus, many pathogens, parasites, etc. So these are the four types in which impurities in water are broadly classified: suspended, colloidal, dissolved, and biological. Now, we were talking about colloidal impurity. right? Colloidal impurity, we were talking in terms of size, that it is having a smaller size than suspended impurities. So, how can colloidal impurities be removed? It cannot be removed by simple filtration, I said. So, there is one method in which by which colloidal impurities can be easily separated by water, is called as addition of coagulant. So, coagulant is nothing but a chemical, like in day-to-day lives, you must have seen that not nowadays we have filters for purifying water, but previously when there were not filters available everywhere, or even today, some people use a chemical called alum to purify our water. So alum is a kind of coagulant. So what we do, the water which is having colloidal impurities, we add to it alum. Alum is a coagulant. So this colloidal impurities are basically negatively charged particles. So they do not settle down in water. You can see the impurities are there in water. They do not settle down. As soon as you add a coagulant like alum, what alum does, it it starts bonding, it adds strongly, absorbing species of opposite charge. That means colloidal impurities are negative in charge. So they are negatively charged, so they are unstable. That is why they do not settle in water. As soon as you add alum, alum forms a bond with it, or you can say it neutralizes the charge, it stabilizes the impurity, and as a result of which the impurities get settled down. So you can add alum into water, you can allow the water to settle for about 1 or 2 days, and then you can simply remove the water. So the impurities would be there at the bottom part. This is called as a process of purifying water by adding coagulant. This method is used for colloidal impurities. Now let's talk about hardness of water. So we know that there are four types of impurities which can be present in water. We saw that suspended impurities can be easily removed by filtration. Colloidal impurities can be removed by addition of chemicals like coagulants. Biological and dissolved impurities require special chemical treatment, which we are going to study further. So, depending upon these types of impurities in water, there are two types of water. Okay, means water can be divided into two types based on the hardness of water. So, what is that? Let us have a look at it. So, one is hard water. So, what is hard water? The water which does not easily produce lather, or you can say foam with soap, is known as a hard water. So it doesn't easily produce lather, rather it produces a white precipitate, a sticky precipitate, which can be called as scum. Another type of water is soft water. So it would be opposite of what hard water is. Soft water is a water which produces foam with soap easily. So this is a simple definition of what is hard water and what is soft water. So here there's a reaction shown while, like how soap reacts with hard water. So this is soap, that is soluble sodium stearate. Okay, we know what is soap. Soap is sodium or potassium salt of higher fatty acids. So this is a sodium salt of higher fatty acid. That means you can see the number of carbon atoms in this fatty acid is C17. So there is much a longer or large number of carbon atoms. So it is called as a higher fatty acid. So this is soap. When soap reacts with calcium chloride, so this is a salt which is present in water, and because of this dissolved salt, the water is hard. So when soap reacts with hard water, it doesn't form lather or foam easily, rather it forms a scum. We said scum is a white precipitate. So this is scum which is formed here. It is insoluble calcium stearate. So you can see the position of sodium in soap is taken by calcium from the salt. Okay, plus NaCl is formed. Second reaction is shown, soluble sodium stearate against soap. It is going to react with the salt present in water, because of which the water is hard. And instead of forming leather, it is going to form the magnesium salt of that soap. Okay, so this is the reaction of hard water with So why water is hard? Water is hard due to presence of salts of different metals which make it hard, like calcium chloride, magnesium sulfate. These are the salts of heavy metals. So the group 2 metals which are there in periodic table, those metals are heavy metals. So salts of those metals makes water. So like here it is said, water is hard due to presence of soluble salt impurities of heavy metals like calcium and magnesium. So it can be calcium chloride, sulfate, nitrate. Similarly, it can be magnesium chloride, sulfate, nitrate, and so on. So carbonates, bicarbonates, and bicarbonates of calcium, magnesium, chlorides, sulfates, nitrates of heavy metals are the hardness causing salts. So let us look at the basic difference between what is hard water and soft water. So hard water, it contains dissolved salts of calcium, magnesium and other heavy metals. Okay, while soft water, it contains mineral salts of Na and K. So sodium and potassium come in the group 1 of periodic table. Those are light metals. So salts of light metals do not make water hard, while salts of heavy metal makes water hard. Then what is the way in which we can distinguish whether it is hard water or soft water? So we know if it is a hard water, it will not produce lather with soap solution easily. Rather, it will form a white precipitate which is scum. Soft water, it easily produces lather with soap, so that is a soft water. And this is again the chemical reaction of soap solution. So we know when we react soap with a hard water, it forms scum, which is actually a salt of heavy metal plus NaCl. While if you are reacting soap with soft water, it easily forms lather, so there is no such reaction which is taking place. So that's all for today's session, friends. In next session, let's discuss more about hardness of water. Thank you.